In section 5.5, we are going to be solving exponential equations. At the top of your page, on page 322 in the Solve It area, I want you to write these three equations. Now, when we solve exponential equations, we're going to be solving equations with the variable as an exponent. So the exponent is going to be your x or your y. So each of these problems has a variable as the exponent. So the first thing you have to do, and we'll get to our key concept in a minute, is you have to make the base on the left equal to a base on the right. So in part A, it says 3 to the x power equals 81. 3 to what power will give you 81? Now most of you could probably figure this out in your head, but the base here is a 3. The base over here needs to be a 3. So we have to rewrite 81 with a base of 3. So 3 to the x power is going to stay the same. 81, we're going to rewrite it. So 3 to what power gives you 81? It'd be 3 to the 4th power. Now that the bases are the same, we can rewrite the equation just using the exponents. So we can say x equals 4, and that would be your equation. Part B, 4 to the x power equals 1/16. 4 to the x equals, we want to rewrite 1/16 as a base of 4. Because the fraction is flipped, we know it has to be a negative power. And 4 to what power gives you 16? It'd be 2. So we know x would equal -2. Part C, 5 to the x minus 2 equals 625. We want to rewrite 625 as a base of 5. So 5, let's see, 5 times 5 is 25, times 5 is 125, times 5 is 625. So that'd be 5 to the 4th power. Now we set our powers equal to each other. X minus 2 equals 4, so I add 2 on both sides. That means I get x equals 6 as my answer. So if you look at the key concept at the bottom of the page, on page 322, it'll say just that. When an exponential equation has the same base on each side of the equation, then the exponents must be equal. And it shows you right there that if b to the x power equals b to the y, then x equals y. So let's look at our got it problem. Problem 1 on page 323. A is 7 to the x power equals 343. We want to rewrite 343, which is the base of 7, which would be 3. 7 to the 3rd power is that. So that must mean that x equals 3. The next one, B. 1 over 216, 1 divided by 216 equals 6 to the x power. We want to rewrite 1 divided by 216 as an exponent with a base of 6. So we know it's going to be negative since it's been flipped. And 6 to what power gives you 216? It'd be 3. Therefore, x equals -3. And lastly, 2 to the x plus 4. We want to rewrite 1 over 1024 divided as a base of 2. So you can just keep working on your calculator and just keep punching in 2 until you get 1024. 2 to the 10th power gives you 1024, so 2 to the -10th would give you 1 divided by 1024. Set your powers equal to each other. X would equal -14. In example problem 2, we're now going to be solving real-world exponential equations. So we'll look at the top of page 324. It says the function r of x equals 2 to the x power represents the number of regions formed when you fold the tablecloth x times. How many folds do you need to make 128 regions? Well, the number of times is x that you fold it, and regions is r. So we're going to plug 128 in for r of x. So our equation would be 2 to the x power equals 128. And we follow the same rules that we just did with section 1. So we have to see 2 to what power gives me 128. Well, we find out that 2 to the 7th power gives you 128. Our bases are both 2 now, so our powers are equal. So x would be 7. And then the question asks how many folds? So this would be 7 folds. In problem 3, we're now going to be solving exponential equations by graphing. So here's what's going to happen. In order to solve exponential equations by graphing, look at the top of page 325. It says you can solve an exponential equation by graphing each side of the equation. The solution is the x-coordinate of the point of intersection of the two graphs. So you're going to graph both sides of this equation, and then on your graph, find the point of intersection, but then we only need the x value, because that's all we need to find is x. So in this problem, we are going to graph 2 different things. We're going to graph y equals 3, and we are going to graph y equals 9 times 3 to the x minus 2. So we're going to graph both of those on the same graph. So I'm counting my y-axis by 3's, and I'm just going to graph the first line. The first line is y equals 3. That would be a horizontal line through 3 on the y-axis. And then now you can just punch the second one into your equation, or into your graphing calculator, and use the table function. Once again, we took this side, set it equal to y equals 3, and we graph it. We take this side, set it equal to y equals 3, or y equals 9 times 3 to the x minus 2. We graph that one. I just made a t-table values of the second equation, which looks something like that. Now, since I graphed it, I can tell you really easily that the point of intersection is 1, 3. But all I need is the value of x. So all I need is the value of x. So x equals 1. Now, if we want to plug in the 1, we can see if it works. And if we do plug it in, we will get 3. So it does work. 9 times, it'd be 3 to the negative 1, which is 9 divided by 3, which is 3 equals 3. So that would make my equation true. So you graph both sides of your equation, plug them in, find the x value at the point of intersection.